Hey, what's up, welders? Welcome to another episode of Adventures in Welding. I'm Paul, and thank you for joining me. I can't believe you're all still there after all these episodes, but hey, that's cool. I'm glad you like hanging out in the shop with me. Today, we're going to talk about one of the most basic welds, probably the most common weld you're ever going to perform. All right, I'll give you a few seconds to guess what it is. Everybody? Got it? Alright, it's the fillet. If you haven't guessed that, the fillet weld is probably the most common weld out there. And I've got some pieces of metal here. And we're going to do some fillet welds with them. We're going to be doing SMAW, shielded metal arc welding, stick welding, because that's probably the easiest way to go about learning to weld, and that's what we're here for, is to help you learn to be a welder. Alright, if you don't know the proper terminology for the parts of the weld, look right here. Pause your video if you want, so that you have an idea. Okay, so you know what we're talking about. Alright, the one thing we're going to be talking about is when we have our fillet weld, which will be the weld that goes right in here, we'll be talking about the face of the weld and the face size of the weld. Now, for instance, this is 3/8 inch thick 1018 mild steel. This is 1/4 inch thick 1018 mild steel. Now, I had used this previously for some TIG practice, so I had to clean it up. That's why it's shiny. These still have the mill scale on them. Basically the same steel though. Alright, so what we're going to be talking about is the face of the weld and face size, or fillet weld size. And here's the key point that I want to get across to you. The fillet weld size need be no larger than the thickness of the thinnest member of the weld. Let me bring you in closer and we'll talk about this better. Alright, now again, when we're talking about a fillet weld, we can be talking about an inside corner joint or a T-joint. We're not talking about the actual joint makeup, we're simply talking about the type of weld, which is the fillet weld. And that is a weld that fills up this area between the horizontal member and the vertical member. I'm calling them horizontal and vertical in this instance. They don't have to be. The joint could be positioned like this. You would be welding here. It would still be a fillet weld. But anyway, so here we have 3/8 inch steel to 3/8 inch steel. And this weld that we're going to lay in here to hold these two together does not need to be any thicker than 3/8 of an inch. If it is any thicker, it's certainly not going to hurt anything, although it may cause some distortion because of the excess heat. It's not going to help anything. Now here we'll be welding a piece of 1/4 inch steel to a piece of 3/8 inch steel. And again, we don't want that fillet weld to be any thicker than this. Anything that's thicker than your thinnest member is wasted metal, wasted material, wasted money, wasted time. Alright, so we'll be doing 3/8 to 3/8 and a 3/8 to 1/4 inch. So you'll be able to see two different thickness sizes in the metal here. So let me get set up and we'll be back and ready to weld. Alright, we've got our test piece tacked up here. I've tacked it on the edges, held everything in place with a magnet to make sure it's all nice and square. And we are going to get ready to weld this up. We're going to be using a 3/32 Lincoln Excalibur 7018 welding rod. We're going to be welding DC, and we're going to be welding the 3/8 to 3/8 at about 90 amps. So let's get the machine set up and we'll come back and we'll get to the welding. Alright, the machine is powered off right now, so I can give you a little demonstration here. And I'm going to be holding the rod in there at a slight angle in the stinger. We're going to come in here and we're going to start right here in this corner, and we're going to keep the rod pointed directly into the joint at about a 45-degree angle, like this. And we're going to have a slight leading angle or a pull angle of about 10 degrees. And this will be a straight drag. This is probably going to take 3 beads to fill up a 3/8 inch fillet weld. But we'll check after each one, since we'll have to chip the slag, and we'll measure it and we'll see how it goes. Alright, after our first pass, let's bring you in a little bit closer. 3, 2, 1. Alright, there is our fillet weld, looking pretty good there. And just because I don't have a really good way to measure, I'm going to take this other piece of 3/8 inch steel and put it on the face like that. And that is pretty much a perfect fit. So we did get our 3/8 inch fillet done in one pass. Not bad at all. Now we'll flip over and do the 1/8 inch. Alright, before we weld the 1/8 inch, we are just going to cool it down a little bit in our quench pot, because we want to start out from basically ambient temperature, just like we did with the thicker side. Alright, in welding this, I thought I'd turn down the amperage to about 75 amps. But as you can watch, the arc kind of wants to snuff itself out here a little bit. That's just too low of an amperage for that rod. And you'll see in the reveal that it just doesn't quite work out. Alright, now I had to turn down the amps to about 75. And I don't like the way that looks at all. Now that looks like crap. So that's going to get another pass. Too low of amps is not a good thing. I didn't want to put down too much material and melt through there, but instead what I did was created a non-viable weld, really. So we're going to go up to 85 amps and run another quick pass in here. Alright, let's see what we got now. That looks much better. But since I had to put that second pass on there, I'm afraid we're a little bit wider than a 1/4 inch. So we do have some wasted weld. But you get the idea of what you got to do here. Alright, sorry for the smoke down here. I don't have the greatest ventilation, but you got an idea about fillet weld sizes and how to control them. You want to use more of your travel speed as opposed to using your amps. By turning the amps down, you're going to affect the quality of the weld. But that's it. Thanks for watching. Don't forget, when we get to 500 subscribers, we'll be giving away 2 argon CO2 regulators. So if you're not a subscriber yet, what are you waiting for? Now get the hell out of my shop. I got stuff to do.